All right, for this review problem, we have the set A is defined to be all integers that are multiples of 20, and B is the set of all integers that are multiples of 10. We want to show that A is a proper subset of B. So there's two things we have to do. We have to show that A is a subset of B, and then we also have to show that there is an element of B that is not an A. So let's list out what we have to do. We will show that A is a subset of B, and then we will show that there is an element of B that is not an element of A. If I can do those two things, then I will show that A is a proper subset of B. So to begin, we prove that A is not B. So step one. Suppose that X is an element of A. I will now show that X is an element of B. By definition, X is an integer. If X is an element of A, that means X is an integer. So that 20 divides X. By definition, there is an integer, I'll call it M, so that X is equal to 20 times M. Okay, that's well and good, but I want to show that 10 is a factor of X. So I'll factor this the obvious way. Therefore, X is equal to 10 times 2M. So I have the 10 all by itself. The thing in parentheses is an integer by the axioms of arithmetic. So 2 is an integer, and M is an integer, and so therefore 2 times M is also an integer. So by definition, 10 divides X. And so 10 divides X, X is an integer, and therefore X is an element of B. So if X is in A, then X is in B, and that proves that A is a subset of B. Step 2. I must find something that is in B that is not in an A. Okay, notice that 30 is in B, since 10 divides 30. So 30 is an integer, 10 divides 30, and so therefore 30 is an element of B. Also, 30 is not in A, since 20 is not a factor of 30. Okay, therefore, we can conclude that A is a proper subset of B, since 30 is in B, but it's not in A. And so that is the end of the proof. And there's nothing special about 30. I could have chose 50. I could have chosen negative 10. Negative 30. Negative 10 would have worked also. Just anything would work that is in B, but not in A.